In this section, we're going to go through a very interesting object injection vulnerability in Joomla 302. This was a serious SQL injection vulnerability in Joomla that had arbitrary command injection and was invoked through object injection. If you're not familiar with Joomla, it's the second most popular content management system on the internet. It's a PHP-based application. After WordPress, it's the most popular, almost on par with Drupal. And it's a relatively large and very dynamic application. It's twice the size of WordPress code-wise. And you can see the vulnerability and the details here. It's a very complicated vulnerability because you have to create an object that then runs a code and then skips a input sanitization and then finally results in an SQL injection. So it also requires the system highlight plugin to be enabled, which is the default configuration, so it's always available. This bug was fixed in Joomla 303 or 259 and existed in versions before that. You can see that in these lines it gets an input from the user in base64 encoding. The input name is highlight, and then it unserializes that input. So there's no check here, as was the case with older applications, so you can create any object that you want here. You can create any of the objects that already exist in Joomla source code, or all the options that already exist in PHP itself. So there are a ton of PHP objects as well. So the exploit here, you can see that it has 5 different objects defined because they inherit from each other. And this is the parameters that we want to set in these. This is the SQL injection that we want. The payload goes in here. So this is the exploit script. And eventually there's an object created from these classes. You can see on the last one to the last line, and then outputs the base64 injection. So let's just run this Joomla.php with this payload. You can see that this is the base64 encoding that we get at the end. It starts from here. Now if I enter this payload as highlight here and see what happens, I see that there's an SQL injection error. And if you look at this error, you can see the OR that I entered here. I entered a single OR because the space was another argument in there. So now I have to input some actual payload that does the injection. You see that it's a relatively large SQL statement, so I have to inject something that doesn't break this SQL. We don't really want to manually analyze this huge query and understand what's happening there. So we use some automated tools such as SQL map, which is a great tool for doing that. But SQL map will obviously not find this because there's a base64 encoding and a very complicated exploit that we need to do here. So we need to let SQL map know where to inject and how to filter its inputs and how to interpret the outputs to understand what's going on. So SQL map will help us a lot here, especially because this is a blind injection vulnerability. So SQL map helps us make this very complicated vulnerability and exploit and turn it into a very simple injection attack into this server. The scripts that we want to attach to SQL map are called Tamper Scripts. They're simple Python codes that filter the inputs and the outputs so that the SQL map can understand it and can communicate with more complicated scenarios and injection examples. So we want to add a tamper to SQL map here that gets the payload but then converts it to that huge base64 thing. So this PHP code was our exploit, and we want to add a Python Tamper script here. So we can either rewrite all that code in Python, which is hard because it uses PHP serialization and we have to model that, or we can just create a Python script that just calls that PHP script. So you can see here, this is a Tamper script in Python for SQL map. It's called Joomla underline Tamper, and you can see that it just runs that PHP script itself and sends the payload to it, and then gets the output and returns that output. So it's a basic wrapper around that PHP exploit payload that receives the payloads and then runs it. So this is our SQL map simple Tamper script, and now with this Tamper script, SQL map should be able to understand that complicated SQL injection and go through it and properly exploit it. So it will create the base64 encoding there, and then because the output is directly shown on the page, we don't need to parse the output. We just need to filter and parse the input. Okay, let's run SQL map with this Tamper script. I'm going to give it the URL that you just saw there, and need to put it in quotes. Then the highlight equals something, star for example, and then I have to give it the Tamper script. I already know the database name. I don't want it to find a database name. I want to make it faster. You know how SQL map works in the previous chapters. Let's take a look at it. Let's show databases. We see that the Joomla table is there. We want to read the CLIDS users table, and the technique we want to use is, because this is a blind injection, if you look at the script and how it works, we want to use a time-based attack. And also, let's see what are in the users table. And you see it has username and password and email. So I want the column, excuse me, the technique is T. The columns are username and password, and that's about it. That's good enough. And dump that out, and then the Tamper script comes here, which is the important part. Joomla.py. Okay, let's run it. So you see that it's a time-based attack now. It understands that the backend is MySQL. Yes. Checking if the injection point on URI parameter number 1 is a false positive. It says the connection dropped. The web server is still working on that. Let's give some more parameters. I'll make the timesec 1 because it's on localhost and it should be fast enough. The default is 5 seconds. DBMS is MySQL, and this should be faster now. So let's just see what's happening here. It's getting a statistical model now, and risk level and testing others. Okay, sure, there are no others. Now it's trying to extract these data. You can see the query that's used. This is the payload that's passed to that thing and turned into base64. Now you should be able to see the data in a second. You see that there's a 1 out there. It's 1 character at a time. Each character requires 7 injections, so that's why it's a little slow, but you see that it's getting it bit by bit out through time-based blind SQL injection, and then giving me 1 character at a time. So we definitely want to extract the sensitive information from that table instead of the full one. So now let's add the verbose config to see the queries that are actually getting passed in there. You see these are the payloads. They get converted into base64. These are the payloads that are being sent to the application, and that's our Tamper script in work. It's converting all of these into base64s and then sending it to that application, then getting the results. You can make it more. 6 will show all the parameters and all the queries, all the HTTP headers, and all of the exact cookie parameters and everything that's being sent there, just for debugging purposes and everything. And v1 is the default. It just shows the successful query once and then extracts the data for us. And we can see that it'll take a while, but we'll see the password get extracted here, and then the username associated with it. So you see that an object injection is not a final attack on its own. We have to find some other vulnerability in the system or some other sensitive stuff. It might be a vulnerability, it might be like information disclosure or interesting errors or adding a user or other things, but object injection enables us to invoke that certain code with the parameter.